Example 1. A rocket expels gas at a rate of 0.4 kg per second. If the average force of the gas is 120 Newton, calculate the velocity of the gas. State the law used in your calculation. Solution. Force is equals to mass m of gas expelled per second times velocity. Force F is equals to mv, which is equals to 0.4 times v, which is equals to 120. Therefore, v is equals to 120 over 0.4, which gives us 300 meters per second. The law used state that the rate of change of momentum equal to the impressed force and take place in the direction of the force. Example 2. If a force of 6.0 Newton acts on a body for 5 seconds, what is the change in momentum? Solution. Change of momentum equals to impulse, which is equals to force times time, which is equals to 6.0 times 5, which gives us 30 kilogram meters per second or 30 Newton seconds. Example 3. A body of mass 2 kg moving with a velocity of 5 meters per second collide with a stationary body of mass 1/2 kg. If the two bodies move together after the impact, calculate the common velocity. Solution. Momentum before impact is equals to m1u, which is equals to 2 times 5, which gives us 10 kg meters per second. Momentum after impact is equals to m1u, which is equals to m1 plus m2 v2, which will give us 10, which is 2 plus half v2. Therefore, v2 is equals to 10 all over in bracket 2 times 1 over 2 to give us 4 meters per second. Therefore, common velocity v2 is equals to 4 meters per second. Note, momentum before impact is equals to momentum after impact. Example 4. A gun of mass 2.0 kg fires a bullet of mass 1.6 times 10 raised to power minus 2 kg due east. What is the required velocity of the gun? Solution. From law of conservation of momentum, Ft is equals to mv minus mu. The total momentum, which initially was 0, unchanged by the explosive impulse, taking the direction of the bullet as positive, you have that 1.6 times 10 raised to power minus 2 times 150 plus bracket minus 2v, which give us 0. 2.4 minus 2v is equals to 0. V is equals to 1.2 meters per second due west. Example 5. If a mass of 50 kg moves a velocity of 36 km per hour, calculate the time taken to bring it to rest by a constant force of 100 Newton. Solution. Since we want to convert the kilometer per hour to meters per second, we divide 36 km per hour with 60 times 60 and times it by 1000, which will now give us 10 meters per second. Initial moment is equal to mass times initial velocity, which is 50 times 10, which gives us 500 kg meters per second. Final moment is equal to 0. Since force times time is the moment change, therefore 100 times t is equal to 500. Therefore, making t the subject of the formula at the time, we have 500 over 100, which will give us 5 seconds. Example 6. A 15-gram bullet traveling at 300 meters per second strikes and it's absorbed by a 75 kilogram object. Find the speed with which the object moved off. Solution. Sum of individual momentum of the bullet and the object before collision is given by m1u1 plus m2u2. This is equals to 15 times 10 raised to power minus 3 kilogram times 300 meters per second plus 75 kilogram times 0, which gives us 4.5 Newton seconds. The mass of objects increased after collision. Therefore, the momentum of the system after collision is in bracket m1 plus m2 close bracket v, which is equals to 0.015 plus 75 kilogram in closing bracket v. From conservation of linear momentum, we have that is 4.5 from before sum of momentum before collision. 4.5 Newton seconds is equals to 75.05 kilogram. That is the sum of momentum increase after the collision. Therefore, making V the subject of the formula, we now have V equals to 0.06 meters per second. Example 7. Calculate the momentum of a mass of 50 grams traveling at 72 km per hour. Solution. Momentum is equals to mv. Mass is equals to 50 grams. To convert it to kilogram, we have 0.05 kilogram. That is dividing 50 divided by 1000. Velocity is in kilometer per hour. To convert it to meters per second, we times 72 by 1000 and divide by 60 times 60. That is 60 minutes and 60 seconds to give us 20 meters per second. Therefore, the momentum is now equals to 0.05 times 20, which will give us 1 Newton seconds. Example 8. A body of mass 2 kg traveling at 3 meters per second increases its speed to 5 meters per second. When a force Fw acts on it for 0.02 seconds, calculate the momentum of force. Solution. Looking at the diagram, giving positive to the direction of force. A body of 2 kg is moving with 3 meters per second and a force is applied for 0.02 seconds, making the body to increase the speed to 5 meters per second. We are now asked to get the momentum of the force. We know that from momentum, Ft is equals to mv minus mu. F, that is the force times time, which is 0.02 seconds, is equals to mass, which is 2 times initial final velocity, which is 5 meters per second, minus mass, which is 2 times initial velocity u, which is 3. Then we now have F 0.02 seconds is equal to 10 minus 6. Making F the subject of the formula, we now have 4 over 0.02 seconds, which will give us 200 Newton. Example 9. A force of 20 Newton acts on a body of mass 2 kg traveling at 4 meters per second for 0.3 seconds in the direction of each motion. What is the final velocity? Solution. Giving positive direction to the force, a body of mass 2 kg is moving with initial velocity 4 meters per second and a force of 20 Newton is applied for 0.3 seconds. We are now asked to determine the final velocity of the body. From the equation of